Hello, this is Teacher Lourdes, and this is your course, Environmental Science. Our lesson 10 is Principles of Population Growth. Our objectives are discuss and explain the principles of population growth, and you will state what you have learned in this lesson in a 2-minute video. This lesson discusses population growth models, including exponential and logistic growth. Exponential growth occurs when resources are unlimited and the population grows rapidly in a J-shaped curve. Logistic growth occurs when resources are limited, causing the population to initially grow rapidly, then slow down, reaching an asymptote as the carrying capacity is approached. Key factors that influence population growth are birth rates, death rates, immigration, food availability, and competition for limited resources. Governments have implemented controls to limit unsustainable human population growth. Are you ready to learn? Let's have the lesson proper. Population growth. Growth models, exponential growth, and logistic growth. The size of a population for any species is not a static parameter. Population keeps changing with time. Population changes depending on various factors like food availability, predation, atmospheric pressure, and adverse weather. The population changes in a given habitat due to changes in four basic processes: natality, mortality, immigration, and emigration. Natality and immigration increase population density. Mortality and emigration decrease population density. Natality refers to the number of births in the population during a given period. Mortality is the number of deaths in the population during a given period. Immigration is the number of individuals of the same species that have come into the habitat from elsewhere during the time period. Emigration is the number of individuals of the population who left the habitat and gone elsewhere during the time period under. Using this diagram, we can show how immigration, natality, mortality, and emigration affect the population density. Immigration and natality adds to population density, while mortality and immigration lessens the population density. The formula is natality plus 1 equals natality plus B plus I minus D plus E. N is the population density at time t. Then its density at time t plus 1 is. Population density will increase if the number of births plus immigrants is more than the number of deaths plus immigrants. For instance, if a new habitat is just being colonized, immigration may contribute more significantly to population growth than birth rates. The growth models, exponential growth and logistic growth. The exponential growth, resource, food, and space availability is essential for the growth of a population. When resources in the habitat are unlimited, each species has potential to grow in number, observed by Darwin while developing his theory of natural selection. When food and space are available, The population of species grows in an exponential or geometric fashion. Darwin showed how even a slow-growing animal like elephant could reach enormous numbers in the absence of checks. If in a population size of n, B equals birth rates and D equals death rates, increase or decrease in n during a unit time period t. This is the formula. The R in this equation is called the intrinsic rate of natural increase. R values for the Norway rat, for example, is 0.015 and the flower beetle is 0.12. In 1981, the R value for human population in India, for example, was 0.0205. When we plot n in relation to time, results in a J-shaped curve. You can see at this plot that the population density is in a J-shaped curve as the population increases. The integral form of the exponential growth equation as NT equals NOERT, and where NT is the population density after time t and NO is the population density at time 0, where R is the intrinsic rate of natural increase and E is the base of natural logarithms with a value of 2.71828. For example, paramecium, starting with just one individual and through binary fission, doubling in numbers every day. Then imagine after 64 days, the population size, the food and space remain unlimited. Now let's have the logistic growth or the Bell-Horst-Burr logistic growth. A population growing in a habitat with limited resources show initially lag phase, acceleration, deceleration, and finally an asymptote or zero. A plot of n in relation to t results in a sigmoid curve. As you can see in this plot, the population density n is increasing. And this is at the time, as you can see in this blue graph, the blue line reached the zero or the asymptote. Using this equation, where n is the population density at time t and r is the intrinsic rate of the natural increase and k is the carrying capacity. K in a given habitat has enough resources to support a maximum possible number, beyond which no further growth is possible. No population of any species in nature has at its disposal unlimited resources to permit exponential growth. This leads to competition between individuals for limited resources. Only the fittest individual will survive and reproduce. The governments of many countries have also realized this fact and introduced various restraints or controls with a view to limit human population growth. This is our resource. Assistant Professor Harinata Reddy Aswarta from Department of Microbiology in India. This is my sources. Thank you for my sources. For your student activity, state what you have learned in this lesson in a 2-minute video and submit it to our Google Classroom in 2 days. I will wait for your output. Thank you and mabuhay!